We can explain how and why things move using some simple laws which Isaac Newton outlined in the 17th century. Newton's laws of motion were first fully revealed in Newton's masterpiece Principia Mathematica, published in 1687. This book, often just called Principia, is one of the most important works in the history of science. In Principia, Newton outlined his laws of motion and introduced his universal law of gravitation. Newton also had to invent new mathematics, calculus, because he needed it for his theories. Calculus is the branch of mathematics which deals with rates of change, and it allows us to calculate instantaneous values for things which are continually changing, things like the velocity of an object at a particular time. There are three laws of motion, and they can be stated as follows. Newton's first law states that an object at rest remains at rest, and an object moving in a straight line at constant velocity remains in that motion unless it is acted on by an external force. This law is called the law of inertia because a body has a natural resistance or inertia to changing its motion. If it is stationary, then it will want to stay at rest. And if it is moving, then it will want to keep moving. And it will require an action, a force, to change the state of the body. So that's the law of inertia, that things keep doing what they're doing unless you do something actively to change it. As an example, imagine you are sitting in a moving car, but you are not wearing a seatbelt. If the car hits a wall and suddenly stops, then Newton's first law tells you two things. One, that the wall has applied a force to the car and so has made it stop. And secondly, and unfortunately for you, you are still moving forward at the same speed that the car was going, and you will keep going until you meet a force which stops you. For example, you hit the dashboard or the windscreen. So that is why seatbelts are needed, because Newton's first law tells us that we need an external force, the tension in the seatbelt, to stop us moving forward when the car has a crash. Newton's second law states that the acceleration of an object depends on the mass of the object and the amount of force that is applied to it. Usually, this law is simply written as the equation F equals ma, and this is probably the most widely applied equation in physics. Simple but incredibly powerful. Anytime something moves, we can work out how much force is involved if we know the mass of the object. The famous example of this is, of course, Newton's observation of an apple falling to the ground at his home and birthplace, Woolsthorpe Manor. Newton wondered what force caused the apple to fall, and we now know, due to Newton's laws, that it was a force due to gravity, which accelerated the apple towards the ground. So anytime anything accelerates, we can calculate the force acting on it using F equals ma. The second law may not be obviously present, but it is involved in almost all actions that we see around us, and it is incredibly important. Newton's third law states that whenever an object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. This law really says that a force acts between objects and that there are no isolated forces acting just in one direction. So if I push on a wall, then the wall pushes back to me with the same amount of force, but in the opposite direction. This is how a rocket takes off, for example. The rocket engines expel gases downwards, but the gases produce an equal and opposite reaction on the rocket to push the rocket upwards. These three laws of motion are immensely powerful, and they are useful in so many scenarios. Whenever something is moving, falling, or there are forces acting on the objects, Newton's laws of motion can be applied to tell us what is happening and why. I hope you found this video interesting. Until next time, keep thinking physics.